I'm Edwin Stang. Yes, I'm Edwin Stang. I've been working as a freelancer for quite some years now, and when I started my studies here in Germany at the FHDW, I also started with working on my own trading platform. Also wrote my master's thesis about this, and I needed to collect my 5 years of work experience to be accepted to a DBA at Heriot-Watt University with the Edinburgh Business School. And that's where I've started to extend my platform to machine learning concepts and generating strategies and so on. This is a long-term dream of mine to have these capabilities, and I'm happy to be able to also publish work on that process and share my knowledge with you and get feedback what you think about this. So the idea is of automating robustness analysis of trading strategy development processes. And this is some sort of AI validation, similar to other things that you discuss, I think, in your group. But I'm more on the empirical side instead of formally verifying these things. So in the agenda, I will go through first the idea I had for this DBA research, then how far I am with the development progress. And then I will present you the expression language that I developed with Hans Wolfgang primarily to be able to formalize these processes that I'm validating. And then I will discuss some possible uses for this and have one example use case for comparing two different trading strategies, types, exactly. So first about the idea, I wanted to increase the automation of trading strategy development. A trading strategy is just deciding when to buy and sell and on a specific market, for example, the DAX or S&P 500. And I just did not want to only formalize these entry and exit rules, which are the actual strategy. I also wanted to do more higher level decision points, for example, risk management, money management, how you scale profit and loss, and doing portfolio and higher level decisions, for example, with handling multiple strategies. And there are quite a lot of literature with specific ideas and approaches for each of these decision points. But I did not see much research about integrating everything into one platform and being able to test this as a whole process. Normally, it's only research about one specific thing. And what I'm interested more about is not just seeing that this works in some specific sample, but I want to see if this works in general over longer periods. So I decided to have machine learning used to simulate random strategy developers using automated strategy generation, specifically evolutionary machine learning. And this is a process that introduces some randomization into the strategy finding process. And I want to test this over a longer period. So, example, repeat this evolutionary machine learning 10 times, for example, within 10 years, and then walk forward each time 1 year out of sample to check if the process produces robust results over a longer time. But instead of just seeing that as a positive result, I also want to measure the actual robustness of the process. So I'm putting another loop on top of that to actually see if the process repeating this walk forward produces similar results multiple times, because it could be luck or bias or whatever that produces positive curve once. So the development progress, I've been working on this trading platform since 2009. It's based on a modular architecture designed for reuse and flexibility. So I wanted to create the perfect basis for developing and researching these things. And in the DBA, as I suggested, I wanted to extend this with machine learning features. And the idea we came up with was having explainable AI. So I was focusing on an expression language. It's a domain-specific language that you can look at, you can debug it, and you can also visualize independent blocks of this to see this visually, how the decisions are made. Also, the expression language is capable not only to automate entry and exit decisions, but also every other decision point that I have. I will explain this later in more detail. And the basis is to be actually able to have these multiple loops with robustness tests and this outer Monte Carlo test. You need a very fast backtesting engine for this. And I think I have made some improvements to what is currently out there with that to be able to research this. With the existing research or work I did on this, there are some UIs also visible. For example, this is a desktop UI where you can debug these expressions. You can see here that individual components are plotted individually, and you can see that the combined result of that is then profitable or not, or follows your decision-making process. You can create reports with this, and you can also see a portfolio here at the top with multiple strategies running simultaneously. This is also live trading capable. There's also the possibility to develop web applications. For example, this semi-automated trading strategy for breakout strategies. I don't want to go into details with this. Just having these charts also in the web was one part of the work that I did. Also, you can do visual backtesting. The backtest is just simulating how trading worked in the past, and you can actually step through this for each point in time and also throttle the speed, increase the speed, and analyze visually specific parts of the history. The same is possible for the web, and this is mainly used for live trading monitoring. I also have lots of reports designed with heat maps, Monte Carlo tests, distribution charts, and so on, efficiency measured, Monte Carlo simulation. I've spent a lot of time with visualizing these things and making them accessible to determine what a good process would look like. You need to be able to look into detail about the specific parts of this. Then for the DBA research, I extended this by genetic programming. A specific process here is exemplary designed here. You have just some pool of building blocks that are indicators. Those indicators are just functions that operate on a price and transform this into some other values to extract some knowledge out of it. And you can combine these into this expression here in the bottom. For example, one indicator with a parameter of 60 is greater than 0, and another rule says, okay, the day of the week should be Monday, and then enter long at market. This is an execution rule to actually start a trade with that. This is, for example, an entry condition. I reproduced this stuff and also made it possible to generate these things similar to here, the genetic operations with mutation and so on. I'm not really using a simple approach like that. I have implemented a differential evolution for this, but I'm also looking into implementing other things which were suggested by Boules, for example, and for the upcoming research and compare these things with each other. But the process is still more or less the same behind it. There's also modularity, so you can replace individual things from that. Also in this DBA research, I developed a portfolio selector. This is a window that can pop up with every time the strategies are generated, and you can actually create filter rules and decisions that can be automated for selecting which candidates you want from these generated strategies. And one of my things that I wanted to test in this research was with my third hypothesis, is it possible to have a process that can beat a benchmark all the time? And I found out this is quite easily achievable because you can see here on the bottom, if you align the same scale for the portfolio and for the candidate itself, so because the portfolio is built out of these candidates that are selected together, when you have on the same scale here on the bottom right, you see it's beating the benchmark quite much because red, green, and yellow lines are the buy and hold and the random benchmarks that I have created. So even with these in-sample, out-of-sample things, it's quite easy. There's also a drop-down here to select different things and so on, but I think I can show this live at the end of the presentation. So about the expression language, I have first in my master's research try to formalize or extract common building blocks from strategies. And with the DBA research, I try to formalize them into expressions. So for example, a trading strategy can be extracted into a variability network that can have multiple decisions for entries and exits, for position sizing, for risk management, and so on. And this changes depending on the strategy, but it's mainly the same building blocks. And you can just vary what options you want there and let the computer then find some profitable strategy from that variability network. But the idea behind this DBA research is make this variability network as large as possible and find an automated process that can filter out good candidates from this to have them traded in the walk forward and do the robustness analysis on this. So I just don't want to have profitable strategies. I want to have profitable selection processes. The same that normally someone does as a portfolio manager that has multiple developers behind him and researchers, and he needs to find out how does he filter out approaches that they present him and which ones will he use for live trading then. I want to formalize these decisions and automate them. The thing behind this formalization is a trading platform. For example, if you don't know about trading in general, an instrument, for example, is a market that you can trade, like these S&P 500, Euro USD, corn, oil, or Bitcoin, or whatever. It's just some price series. A bar that we speak about normally is an aggregation of this price series. So you can have an open, high, low, and close, and can plot this in a chart and so on, and also run indicators on that to transform the prices to get some knowledge out of it and combine it in some way that can perform an entry or exit signal. And an order is actually then the execution of this entry or exit signal to buy or sell at the market, which is executed by the broker for you, which I simulate here normally, and it just tracks the profit and loss. But I can also replace this broker implementation with a real broker. I have multiple connectivities there, and we can also run this live by pressing a button. If you look at individual decision points, there are always an example of having an action, that's my decision point, which is defined by a guard or constraints that you normally talk about in language design, but I also have included side effects where it's useful. For example, a trade execution or manipulating an existing trade as a broker is always a side effect, but I want these because a normal functional programming language works without them. So formalization and doing validations on this without side effects would be easier, but I have to do this with side effects. Things that I have, you can pre-process these bars that are the aggregation of prices to have different robustness things or manipulate the price, randomize it, or generate your own artificial prices and so on. But you can also combine them in different ways by just time with different time zones or doing price ranges based on some sort of volatility, which could be the standard deviation or something. And you can also use this expression language to define these transformations. So there's multiple cases where I can reuse this expression language design. For entries, you can just, for example, do two averages in comparison combined with some kind of indicator that is checked against a threshold and execute this either by profiting from rising prices or from falling prices or having a strategy that is always on the market to reverse based on if this becomes true or false and then profiting primarily on the higher side or on the lower side. These are multiple things that you can analyze with this. And also with exit conditions, you can reuse this entry condition, say, okay, when this becomes invalid, I want to exit, or you can also do some signals to the broker, for example, stop this trade if it reaches a specific price target, and this is also a nested expression that you can use for that. These are just examples that are simplified. In my implementation, I have thousands of indicators implemented that I am running through this machine learning algorithm. The decision points for risk, for example, you can manipulate the different types of orders, which we can also look at later in the machine learning process that I have results about. Normal types are, for example, market, or this is just executed at a given price. It's a market that is currently available, or you can set a limit that you want to have at least, or you can say a stop. I want to wait for that price and then execute at market. And you can define these price levels also as expressions. And you can also embed this into the entry condition by just adding another rule, enter long at limit, for example, with this price target. And you can also put multiple entries at the same time and so on. So you can vary with different side effects, which I've marked as underscored. For money management, I'm still working on formalizing this, but I already have this implemented in Java. Just some fixed amount, you can do this weighted, or do also some optimization, or also evolutionary algorithm for this optimal F to have different weights for strategy candidates or individual trades itself. And you can also do something that is called equity curve trading. You actually look at not so just prices of the market to do some rules on it, but you can also generate an equity curve, that's a profit and loss curve of the strategy that is running, and see this as a price curve and then run rules on that. For example, you can stop trading a strategy if the losses today exceeds 3. So if I have 3 loss trades, I stop trading for that day and start trading the next day. Or if the risk that is currently exposed at the strategy, I don't allow more trades if the risk is exceeding 30% of my account currently. Because, for example, the maximum loss of each trade combined would wipe out my account by 30% if a large move occurs. This is also based, you can do basis on individual strategies or on the portfolio itself, because each level can create its own curve. But this is all the same expression language, and it can be reused for this, and I can also generate these decision points individually with the same algorithms. On a higher level, that's what I'm more interested in right now, is the selection process, where you can, when the strategy generation gives you candidate strategies, I want to find a good filter that checks if the candidate is profitable or not, because there are lots of false positives. This block can then filter out, hopefully, these unprofitable false candidates, because the out of sample, for example, could be bad, while the in sample that the machine learning algorithm saw could be good, and I want to filter based on the out sample. But I also found some counterintuitive results with this, because sometimes having a larger sample, in sample filtering might be better and so on. So there's lots of experimentations there. But you can also do complex analysis here, for example, run a wise reality check or some efficiency or statistical test and so on. You can do very complex things for these rules here. Also, I'm currently working on nested optimization. So instead of just having an entry signal where you have one fixed value, you can run a nested optimization for this and let the machine learning algorithm actually operate on an optimized variable. So it's more like what the human normally does with this manual optimizations. He can look at the distribution of strategy candidates behind one strategy and then look at how it performs robust on its own robustness test. So I can nest multiple robustness levels with this. And also the auto robustness checking, you can write expressions in the strategy filter, for example, with I want the probability of luck with this specific test below 5%, or I want the efficiency of having in sample and out samples compared better than 50%, which would be a robust strategy. Or I can also do Monte Carlo tests with reshuffled trading trades and so on, and do my tests on that to have a statistically significant result of the drawdown, for example, that I want to limit theoretically to 15%. The language design behind this is I've written a domain-specific language for this. It's kind of functional style because you don't have loops or something like that, but I also wanted to simplify it a lot with making the problem space smaller, removing exception cases and so on. So the rules should always produce a valid result, or say don't trade even with corrupt or bad values that come into it. And also the language assertions and so on should be proper, so that you cannot write incorrect expressions. And if you do some invalid combinations of indicators and so on, it should not limit you and should just stop trading if it's not working. Because in time series, if you have a long series of values, maybe there are some periods where some invalid results are occurring. You don't want the strategy to stop at this case, you just want to ignore this data. So also I've removed the collections, lists, and types and so on. Everything can be interpreted as a double value series, just some time indexed values that represent some sort of price. For example, high, open, high, low, close. Each of these values is its own double series with a time index. And also each indicator is represented as a double series. And you can combine these Boolean expressions and so on just by checking if a value is above 1 or 0, above or equal 1 or 0, and just do my Boolean operation. So behind the scenes, actual implementations are actually using different types to have optimized execution on this, because actually using double is quite fast, but not fast enough for lots of cases. But still, the expression language sees everything as a double, and it can also interpret everything as a double. There's also the thing that you can interchange functions and variables. It's also, you can just, for nullary functions, you can remove the parameters, but also for optional parameters, you just don't give them, they stay the default, and the functions can be created dynamically in that regard. The language design on the second part is it's case insensitive, and nesting is allowed, so you can put functions as arguments for another function or multiple ones and nest this arbitrarily. The functions are actually not defined in the expression language itself, but actually in the trading platform around it, and it's adding metadata and so on, so I can do code completions and documentation assistance and so on that are normally used from normal development environments. And actually, I wrote here things that vars are not supported. You can actually right now also write, for example, var function or var variable equals another expression, and then reuse this as a statement to use this new variable name in other functions. This is something that I'm currently working on. But the indexing normally for this time series, you can differentiate between normal dates, that's actually a timestamp. For live executions, for example, it's best suited because you can have multiple inputs for multiple data sources, and then you need to just align them via the actual date. But for the actual machine learning, this is too slow if you run this with file access and indexes based on timestamps and so on. So I also have the int-based lookups and have a special in-memory engine that only does this int-based behind the scenes. But you can still do expressions for indexing. So it's the close to expression says, okay, give me the value 2 bars back or 2 timestamps back. Or you can also do lookups of this, for example, to go 3 days back and so on. I created the strategy also with the help of Hans Wolfgang to be non-strict. So these problem cases that I spoke about with exception cases and so on are handled as none or null. And so this is interchangeable, and then handle this as neutral or missing. So for example, if you do a Boolean comparison with AND, with a none value and a true value, the none is just ignored and it becomes still true. So this is simplification that also improves the ways in which you can represent trading rules or other building blocks with this expression language. But this is a deviation from the normal IEEE standard for handling these nonce. I also have aggregate functions that work on this series, that they can do lookups, they can simulate an if function, you can do ensemble strategies with a vote function to have multiple rules combined into a threshold and then decide based on that. Or you can just check if the result is stable over how many timestamps backend, or if something occurs, for example, within the last 3 days and so on, and then use this as a current value to the current decision point. Because you always step from one timestamp to the next. You can only look back, but you always decide on the current timestamp. That's what the engine around this does, because the evaluation of these expressions always happens for each timestamp. So the performance of this becomes crucial to actually have this fast enough. So regarding the implementation, there was lots of consideration how this should be done. This is implemented in Java as an object-oriented implementation with the focus of high performance. It's using, to get this high performance final and immutable where possible. It tries to do zero copies and tries to not do any allocations during the execution. So everything needs to be pre-passed and be final as possible and so on. So the evaluation as fast as possible. And I found an expression language implementation called Parsi. Here's the source for that. And it's claiming to be the fastest one that is currently available for Java. And I think I also researched this for multiple other languages. But I still found this as a very good basis because it's a simple implementation. But also I found lots of ways to still improve this by extending the language features, for example, for this time-based lookups, for having this robustness for non-values and so on. And also to put around this trading platform context around it. But this is actually optional because you can also replace this context for different decisions. For example, instead of having this operated on prices, you can also operate this on results, statistical results for a backtest itself for one strategy candidate, and then run expressions on these candidates, for example. But I think the thing that put the most performance benefit behind this was not actually parsing the expressions that normally represent the strings, but actually combining them as objects in Java, because this has lots of less overhead. And this is also the only thing that is needed for machine learning, because it just can combine pre-existing blocks into one new expression and then just execute that. And here you see why the speed is important, or how I compare this to Parsi. I put in lots of new optimizations for actually evaluating these entry conditions here, for example. And there's, for example, constants are extracted. So for example, this 2 plus 7 minus 5 is extracted and put into one constant double value. And functions that are variable, for example, this close function is always evaluated live with each timestamp. But other things are just then transformed into constant values. This makes it possible to have this result. Here you have differentiation between parsing, where I parse this string each time I evaluate this, or with caching, reusing these expressions that are parsed. This is working on 20 years of daily bars. Daily just means open, high, low, close of each day. I'm running this on an i9, and RAM is irrelevant for this test because with daily data, the granularity is high enough that it's all fitting into the CPU cache. And one thing that I did behind this, you can see here the bars. This is each timestamp evaluation itself. And the strategies are actually iterations through the series. This is an actual backtest that executes this thousands or hundreds of thousands of times. And you can see that the performance between Parsi and the new implementation sometimes exceeds tenfold. But there are also some other things that are available in Java, for example, Spring or Groovy, some people know maybe. Because of the compilation overhead, it's very slow in comparison. But with, for example, changing the storage behind it, not having this evaluated as a double with these end combination and so on based on doubles and so on, you can actually trim this down as a bit set. This is a long representation of the values with each bit representing one Boolean. If you chunk this down into that, so the double is not an array anymore, but a bit set, you can have improvements of this and have this close, for example, decision against the threshold as a bit set. Then the lookup becomes a lot faster. You don't have to do lots of memory lookups for that and so on. And the performance goes through the roof, and it just doesn't matter anymore what indicators behind it. It's just pre-calculated ones, and the execution is then indifferent to the expression that is used. And it's always in that regard to have the possibility to run 200,000 strategies per second, or with one thread, for example, 1.5 million strategies backtests per second with 12 threads. So regarding possible uses of this, I'm comparing here with the next few slides just two types of strategies. There are some things, trend following or mean reversion, and some other things like signal or breakout. This is just some specific types of strategies that you can classify in some way. I'm just picking two candidates that I found sources for, re-implemented them, and try to have them run against each other in this robustness test that I'm showing later. And for the machine learning techniques, we could also do comparison not on different strategy types, but on machine learning techniques, for example, checking if differential evolution is worse than harmony search, symbiotic organisms, or some combination of these things like extreme learning. That's something I would like to do later. But also later I want to do some uniformization, so you can also compare evolutionary strategy generation processes with neural networks or support vector machines or something else. So I want to have a benchmark framework to test machine learning approaches and robustness tests and processes and so on. And you can also test these robustness approaches or processes on a different level, and then, for example, test if walk-forward analysis, it does these each following out sample checks. Maybe it does not perform better than cross-validation or some sort of statistical measure that I'm doing based on some other paper that I'm reading. I can just implement these things and then just test them against each other. It's reusing the same platform. And because everything is built by the same platform, it's adding a lot of flexibility. Because if you want to try to do this with an existing solution, with an existing trading platform, it's always limiting you what you can do with the architecture. And because also in the live trading and so on, I can't run these things anymore on the other platform. I have to implement live trading myself because they just don't offer these features that I require for executing the strategies, and re-implementing them would be too much work. So with this automated process, with an actual live test for this, I tested with this machine learning algorithm, I can generate, for example, 140,000 strategy candidates or up to 1.6 million backtests or strategy candidates per second that I can then filter and so on. This is a lot faster than existing trading or tools out there can do. It's 4 to 8 times faster than the fastest alternative that I can find. And this so depends with this execution performance on the time range that you pick. For example, higher granularity with more timestamps is slower linearly. And also how many simulated trades happen, because the trade execution simulation is slower. A strategy that trades multiple thousands of times is a bit slower than a strategy that trades less. But I also did some optimizations with the bit sets to just skip some values. So, for example, if it's always false, most strategies are false all the time in the time series, then it just skips until the next point where the value is true again to execute its trades there. Yeah, and also other alternative platforms there normally only automate entry and exit decision points. They only allow you to compare different markets instead of having this longitudinal test with this walk forwards and so on that they offer. And they don't do the significance test on the outside, because I think they don't have the speed that is required for doing this additional loop and so on, because you need high performance to do these additional outer tests. So going into the actual examples of these strategies, for example, a signal strategy, I just got the idea from another tool called Build Alpha. That's also one of the fastest that I found. And also I found this a simple approach to optimize on. So these entries are just a combination of multiple signals. That are these things that compare an indicator with another indicator or just two thresholds or whatever. And you can also do the same for an exit rule. If you compare this with a breakout strategy, this is not based on just some, now it's the time, now enter a trade on the market. I can do a calculation based on some comparison. If the market reaches a specific price target, then I want to enter this trade. And for this, I bought a course here on Better Trader Academy. They specialize on these breakout strategies, and I just reproduced some simple examples from them and did some extensions on my own, just some to have some basis for this to compare them. And this is based on a filter language, filter expression that can be multiple signals like here that are combined, or just one that says, okay, now it's a time or not. And then the actual price target is defined as some sort of level. That could be the close price of the last day or whatever. And then some volatility with a factor is added. For example, the standard deviation of the last few days is then added to this price target. So I enter, for example, at 2.5 standard deviations from the last days based on the last close price. So this is the last price that was at the end of last day. And I can do the same for both sides at the same strategy and then just filter them individually, but I can execute multiple trades at the same time. And the exit is always exit at the end of the day. And then it's executing always maximum 1 day or less, because it can actually start a trade in the middle of the day when the price target is reached. The test setup for this is a foreign exchange market, because I have a good source of data for that from Lucas Copy Broker. It's tick based, so it's smallest granularity, and I just aggregate this. For example, a tick is one price point, and I aggregate this to bars to have this daily bars that are defined here as a time aggregation based on 1 day on the UTC time zone. And this makes the test a lot faster, but you can also differentiate these tests on different time frames or bar types and so on, because some machine learning books say you should not do this on some arbitrary aggregation based on time, but you should do this based on some price movement and so on, because this is a better representation of the movements in the day, instead of having this arbitrary cut at the start and the end of the day or whatever. And here I compare with these two strategy types. The signal-based one only execute market trades, and the breakout strategy executes stop limit, and market touch. Those are a bit more exotic trade types, the last two, but this is just some price targets that I check against. And the two strategies, I'm actually comparing here apples with oranges. The signal-based strategy always executes only long trades, and the breakout strategy is using both long and short in an OR combination. So I can only be one side at a time, but I can actually have rules that start this at a specific time. And I'm just making this as simple as possible for the other rules. I have the money manual, so the actual trade size, how many units do I want to trade from this stock or index or whatever I want. I'm always using the minimum amounts that the broker allows. And also the strategy filter, it's ranking the strategy candidates, which can be multiple thousands candidates that I want to look at, then just filter out the top 10 based on the in-sample result of the execution. You should normally not do this, because in-sample is not a robust measure, but I show you some interesting things that I found out with that in the next few slides. And also I run this in a walk-forward analysis. I use 6 years as a look-back period. For example, I always let the strategy generation process look at 6 years, find the best strategies in this period, and then use the selected strategies based on this filter for the next year out. And then it starts again at this next year, look back 6 years again, and then go another year forward. So it's repeating this process multiple times. And it's actually here a step size of 10 years. And it's going from 2010 to 2020. So it's actually starting from 2004, because you need to subtract 6 years from 2010 to actually have the first look back. But the out sample is only from 2010 to 2020. Here is the out sample result of this walk forward. So each year here, 10 new strategies were picked, and it's executed in this Euro USD foreign exchange curve. It's just some prices that are used as a basis. You can replace it with anything else, or even do artificial price generation. And here you can see, okay, the signals are quite random in the result, but for example, the breakout strategies are a bit more profitable. So it's still having some periods where it's not so profitable. And you can also see here that the overall maximum result was here 1,500, and here on the right side 2,500. So this is just one execution of this. So I don't know if this is robust or not, but let's see what the robustness test shows. But just on a glance, I would say, okay, maybe breakout strategies are more interesting. This is a visualization of the actual walk-forward analysis, because in the next slide I will show measures that I'm extracting for this. So this test here with this 10 years, is represented as this in-sample and out-sample periods, and I'm just concatenating these out-sample results to have this price curve generated that I'm having here. So this is these out-sample results. And I can actually compare the in-sample result of each one with its corresponding out-sample result. And if the in-sample result of the profit, for example, is within 50% of the out-sample result, then, for example, I could say, okay, maybe this is a robust strategy, but actually the out-sample results can also exceed the in-sample results in some cases. But an alternative to this analysis could be cross-validation, where you just mix these things and have out-samples, reuse samples, and so on. This is a way that I just align this and only do it forward like you would do in live trading as a real portfolio manager. And
hi, Edwin. Sorry, just to say that you have about 5 minutes left. And
yes, I have 3 more slides. I think we should make it. And here you can see the walk-forward efficiency, where you compare the in-sample and out-sample of the signal strategy is quite low. It's only, for example, 16%. And with the breakout strategies, we have like 50%, which nears the robust strategy, I would say. I also did White's reality check on this. This is a special paper that does this analysis on detrended data. So it's always starting and ending at the same prices, and just looks at random strategies, monkeys that type in entries and exits and so on, to actually have some sort of random benchmark to check against. And you can see here the probability of luck that results from this distribution for the signal is a lot worse than for the breakout strategy, but it's still quite high for the probability of luck. And for the Monte Carlo analysis, this is the outer sample analysis that I want to do. I actually repeat this whole process 200 times, for example, and then check if the distribution of these out sample results, where I repeat the whole process multiple times, how does it deviate from each time, how is the randomization mitigated. And this is, I think, the best robustness test that I can do here to actually see if this approach, the process that I'm using, is viable or not. And this is the result for that. You can see here the span of the signals is a bit higher than for the breakout strategies. So the range here is smaller, so this might be a better approach. And the significance test here, for example, with the 99% confidence level, says, okay, I should make about 1,500 euro or whatever minimum with this, but with the signal strategy, which is much more random, has a less result here. And this is the most expensive test that I can do here, but this is still doable within a few minutes or hours, depending on the process. And here I have a drill down. So actually the things that I've included here for the breakout strategies includes lots of bad candidates, and the process, even with the in-sample filtering only, can filter out something that is profitable here at the bottom, but it's actually having candidates behind this. If I limit this only to these candidates, it's having an efficiency above 100% in some examples. But still, even this here is just an accident that I did with this generation process. If you actually combine this with more options, increasing the problem space and so on, you actually introduce more candidates in that. So it's a lot more false positives, and the process again becomes more like this signal space, because currently this test here for signals has a lot more rule candidates than the breakout one. I think this is more the driver behind this, because the breakout has less bad candidates it needs to filter. But still, for the later research, I want to find out what process can remove these false positives, and I want to do this without my own human bias, because I know these candidates are better than the others. I don't want to influence this in my process that I'm automating. So I want to remove the human decision making from that. So that's it. I hope I did not lose too many of you in the process, but I think we have a few minutes for some questions. So I'm happy to hear your thoughts about this. If you have some requests or something, I also have some additional papers for this, and I can also give access to the trading platform itself. You just need to ask me, and then we can talk about this. But the idea here is the platforms that I'm building should become a tool that can be used for other researchers to do these tests that are currently not possible and are not really done in papers currently, as I see. So thanks for your attention.
Thanks a lot, Edwin. Sorry, I have to go essentially in 3 minutes. So team, but the team can stay and discuss it a little bit longer. As I understand it, Matthew, yeah, the platform is set up to be used after we leave.
Yes. Yeah, I'm afraid I also need to go in 2 minutes.
Okay. Well, anyway, questions in the remaining few minutes?
Yeah, I think I had a question. Adam, I just want